Hello everybody, this is Lorenzo Perella for Physics 116 with Clark Wellman. Today I'm going over quiz 6 involving concave mirrors and geometric optics. That quick slide there was just a fancy thing going through the PowerPoint just to make me remind about geometric optics. Anyway, we're given a concave mirror with a radius of 320 millimeters for its curvature. And a mirror is used for shaving by a person whose face is 120 millimeters to the left of its vertex. Using the mirror equations, we need to solve questions 1 through 4. So for the purpose of this video, we just need to talk about number 1, which is where is the image of the face? Now in this case, what we have here is the mirror. Here's the concave mirror. This S here is the distance that is between the face and the vertex, which is S. Here is the focus point. And at this point, we have the light that's bouncing and receiving back to the focus point. However, it actually should be pointing out this way because we're trying to find the focus length. The image distance, which is S prime, can be seen here. So first we need to find the focal length, which is 160 millimeters, and we get that by taking the radius of curvature divided by 2. Then, in order to find our image distance, we need to take the inverse of the object distance and subtract that by the inverse of the focal length. Now my calculations here are incorrect, but luckily I had another piece of paper to do the corrections for this. Now as we can see, 1 over S prime is 160 millimeters minus 120 millimeters, which is negative 0.00208 millimeters. And when the inverse of that value, we get negative 480 millimeters, which is then located to the right of the vertex. Now this distance is much greater than the distance of the face to the mirror because the light is being amplified from this mirror. And a good way of thinking of this is thinking about a spoon, and that when you look at your reflection in a spoon or any other kind of reflection, you see yourself, but that image, whether it be smaller or larger, isn't actually there. It's a virtual image because while it is being seen because of the light, there is no actual image there, so it's not receiving any light for that image itself, which would then make that image virtual. And in the case of this mirror, it would actually create an erected image. But that's more about explaining the rest of the pieces. Anyway, the main takeaway from this is that when you're using an image, that when you have a concave mirror and an image a set distance away from the vertex, the object distance has a magnitude that is multiplied by 4 times that of the object length, relatively speaking. Also, 360 and 120 is 480. So another way to think about it is that the distance is relative to the radius of curvature plus the focal length. Oh no, the length between the vertex and the object in relatives terms. Thank you. This has been Lorenzo Perella for Physics 116 with Clark Wellman. I hope you found this helpful and you have a great day.